So thank you for coming out on a pretty wet, cold winter's night. Sort of thought winter was over. Winter was over, actually. Just a real shame that the ski field shuts down this weekend. Look, by way of introduction, my name is Mike Scott. I'm the Chief Executive of Waimea Water Limited, and I have some colleagues here with me tonight. Justin McDowell is the New Zealand Manager for Projects with Fulton Hogan. Matt down the back is with Taylor's. We have Ian Loney, my design and project engineer, who will give you an update on design today. And Peter Amos is joining us today. So Peter is the Chief Executive and Managing Director of DamWatch, one of the consulting engineers that are supporting us. So you've got some of the key figures today to help give you an update on the project. So the intent today is to, maybe just go to the next slide, Amy. Look, the headline is we're underway. We had our groundbreaking ceremony on the 9th of August, and we are well and truly into the guts of the project now, and we'll come back to what we're doing shortly. We're pretty happy the way it's going. The geology is as expected so far, and we're pretty much where we wanted to be with the schedule, notwithstanding that we started late with the drought and fire risk at the start of the year. So over the next 30 minutes or so, what I'd like to do is provide you with an update or an overview of design. Looking at the questions that came in the last week, there's a lot of questions around design, seismic load, flood load, and how do we come up with design. So Ian, our dam engineer, will provide you with a bit of an overview as to how we got the design we got. And then I'll provide a update on construction of the project, which is really just a series of photos that shows you what's going on site. We've got an update on the environmental work we're doing on site to tell you what we're doing about managing the environmental aspects both on site but also part of the biodiversity management program off-site as well. And then to the fun part of this evening, which is the Q&A session. And we've got 45 minutes to answer questions. Thank you to those of you who sent your questions in. Really appreciate it. We've got a really good bunch of questions, and we'll work through those, and then if time permits at the end, we can probably go to the floor. So hopefully it works for everyone. So by way of introduction, Ian is our dam engineer working with Waimea Water Limited. Ian joined us early in the year. Ian has a degree, Bachelor of Engineering from Auckland, and a Master's in Geotech Engineering from New South Wales.
Yeah, that's right.
Yeah, and then worked for both GHD and then SMEC in Queensland. So got a lot of good dam experience, and then couldn't resist the temptation to come and build this awesome project. So we lured him over to Richmond. So Ian will provide an overview of the design, and then we'll come back to questions later.
Yeah, great. It's quite a special opportunity to actually get to build a dam from scratch, which is why, as Mike says, I couldn't say no to the opportunity to move over here and work on the project. Moving from Brisbane to Tasman in the middle of winter was quite a challenge to me and the family. We very quickly found that our cold weather gear from Brisbane doesn't quite cut it in the South Island in June. I've only got a few slides here, and most of them are some text and facts and figures and fairly boring. So we thought we'd jazz it up with a few photos to keep the interest up. Over on the left-hand side there, it's a 3D model representing the dam overlaid on the topography. Yeah, you can see the embankment on the sort of far left, and towards the centre of the photo, centre of that model is the spillway coming down and re-entering the river. On the right-hand side here, it's another CFRD dam. up in Palmerston North, which has been around for a bit over 100 years. And it's been through a couple of rounds of upgrades, but still going strong.
Speak up.
Oh, pardon me, of course. Next slide. So our dam here, so we're building a concrete faced rock fill dam, which is essentially graded rock fill with a concrete membrane on the upstream side. The concrete membrane itself is sort of tied into the geology through a sort of heavily reinforced concrete plinth, which then sort of grouted to provide a watertight seal around the dam. The rock itself is all sourced from the site, and there's about 430,000 cubic metres of rock that we'll mine from the site and use to construct the dam. The type of dam was chosen as it's probably the most robust dam type for the location. Being in the South Island, we're operating in quite a high seismic zone, so the concrete faced rockfill dam can tolerate the deformation of the settlements associated with an earthquake probably a bit better than an earth embankment dam or a concrete dam could. Eventually, when it's constructed, it'll be a 53 metre high embankment, 220 metres long, and will store a reservoir of 13 million cubic metres. Two of the key design features that we designed a dam for are earthquake loading, particularly relevant here in the South Island, and flood loading as well. So the two earthquake loads that we've designed the dam for are the operating basis earthquake, which is a 1 in 150 year event, and a seismic evaluation basis earthquake, which is a 1 in 10,000 year event in this case. The operating basis earthquake is intended that the structure will still remain operational. May receive some superficial damage, but all the systems and plant at the dam will remain operational. And the seismic evaluation earthquake is a much larger event, as you can see. And the intention behind design for that event is that there's no uncontrolled release of the reservoir contents. So there may be some damage to the structure, but it will remain safe. So that's driven by a couple of fairly close faults to the site, sort of 8 and 12 kilometres nearby, which really dominate those sort of horizontal accelerations associated with those earthquake events. So you can see there the earthquake accelerations are ranging between 0.64 and 1.65 G. So 0.64 times gravity and 1.65 times gravity, which you can imagine are fairly substantial loads for the structure. The flood event that we've designed for is the maximum, or probable maximum flood, which is the largest design event that is required to be designed to under the standards. And probably similarly for that SEE, the seismic evaluation earthquake, that is also the sort of highest standard of earthquake design that we can design to. So the spillway size for the PMF flood, which is just a bit under 1100 cumex. For comparison, the flood on the 12th of May of this year was about 250 cumex. So you can see that flood we've designed for is just a touch over 4 times the size of that. The outlet works, so water is delivered on the river. So the outlet works of the dam will be operated to deliver water onto the river to replenish the downstream aquifers. The range of flows out of that sort of range between 0.5 cumex, which is an environmental minimum flow to maintain river health, right the way through to sort of 5 cumex for delivery of water to the downstream aquifers. The outlet works also allow for a drawdown scenario, which is this 17 cumex level you can see there, which is sufficient to drop about 10% of the reservoir each day. So that drawdown requirement is quite important. In the event that we do have an earthquake or something unusual is detected in the operation of the dam, that gives us the ability to draw the reservoir down quite quickly to sort of gain control of the situation and make the structure safe. So I already touched on the design standards a little bit. So those two key design criteria we're designing for, earthquake and flood, the highest possible criteria that we can do under the standards. Come in. Evening. Evening. So during construction, we've engaged Downwatch to provide some support. Essentially, their focus is on any design optimisation or adjustments that are required to suit ground conditions that we encounter. They also have a role in overseeing the quality assurance on the project and in ensuring the project is built to the design, to the drawings and the spec. There's a few activities that they're going through at the moment for us. So we've essentially started opening up the ground and making a few adjustments to suit what we're finding. One of which is optimisation of the embankment zoning, essentially to increase the drainage to the base here, and there'll also be some adjustments to the some drainage layers behind the concrete face on the upstream side here, primarily to make the best use of the materials we've had on site in the body of the dam. So by increasing the drainage capacity through here, that gives a lot more flexibility about the material that we can put into the body of the dam. The spillway has been tweaked a little bit to solve a few of the design features that were in there last time. There's also been a little bit of adjustment there to the geology that we found. That's been modifications to the number of anchors and the drainage beneath the spillway. So there's been a couple of high-profile spillway incidents recently over in the US at Oroville and Toddbrook in the UK. And those two failures were sort of around foundation conditions, drainage, anchoring. So there's been a lot of focus on that recently, and it's sort of one of the hot topics that Downwatch have been assisting us with to make sure we get this right and don't repeat those failures from those two. The plinth design and ground spec has been reviewed and adjusted to better suit the geology that we've encountered. And there's also been a body of work to look at how that works and to facilitate the incorporation of hydropower into the scheme at a later date.
Right. Thank you. That's fine. Thank you. Just go back one for a second. Thank you. This diagram on the bottom right. This shows the bore logs that we've taken over time. There's been a little bit of scatterbuck and talk about bore logs and not finding bedrock. What this shows is where our bore logs have been taken. So we've taken 17 bore logs over almost 10 years. The last bore logs we took were in 2017, and they were around some of the outside here. And so we have not had two drilling crews on site for 6 weeks searching for rock. That is not correct. And so far we're pretty happy with the geology. It's in line with what we saw in these bore logs, or even slightly better in places. So we're pretty happy with the geology so far. So look, we'll talk about where we're at with construction now. And I guess the headline I'd like you to take away tonight is we're very happy with the way things are going. Yeah, we have arguably the best combination of contractors in New Zealand building this, Fulton, Hogan and Taylors, and they have the experience, the people, and they're doing a cracking job. We have one of the leading dam engineering companies in the region, Downwatch, supporting us. So we have the right people, we have the right team, and so far, early days, albeit it's delivering. So very pleased with the start we've made. So with construction, we started in the middle of March. we've pretty much got the access roads near completion. The bridges are happening. The haulage roads are happening, done. The concrete batching plant is pretty much operational, and a lot of the work in the last few weeks has really been on clearing the abutments, and we'll show you what that looks like shortly, and getting ready for the plinth, and we'll come back to that shortly as well. The river's been moved to the left-hand side in preparation for a culvert, and as you can see, the vegetation clearance is also progressing well, and we're making good progress through getting the vegetation away from the reservoir footprint and the dam footprint. This photo here, this is looking down the valley, so the river's flowing down here. This is the true left-hand side abutment, and you can see the sediment pond down the bottom to catch sediment runoff. This is the abutment face coming down here, and in the background, well, it's not particularly clear. You can see the right-hand abutment.
So that left has got rock in it?
It's got rock. So yep, we'll show you some photos. So there it is.
Oh, okay.
So this is looking at the left-hand side abutment, and as I said before, it's pretty much as we expected, and even slightly better in places. You can see here, Matt's going to correct me if I get this wrong, that Matt and his guys have been basically pulling the overburden back off this rock here. So you can see that this is the bedrock that the embankment will be built on, and that they're pulling back the overburden and getting ready for the abutment to be laid up later on. So here's the same photo over here. This is looking from the right-hand side, so you can see we're standing on some pretty hard rock there, which is essentially where the plinth will be start from, and we have good rock on the right-hand side, looking across to the left-hand side. What you can see just up the top here is the top of the plinth line.
That'll be the height of the dam.
Sorry?
Will that be the height of the dam?
Yeah, look, I've got a better picture coming up actually, Amy, if you just want to scroll through one. So this shows the same progress, but from a different angle. This is obviously the aerial photo. To your question, sir, earlier, this is the bedrock at the bottom that we're sort of peeling back. That the guys, Matt and his guys, are sort of peeling back the overburden from. Very happy with the nice, hard, shiny rock we're finding there. What you see in this aerial photo here, here's that exposed rock as well, and you can see the overburden being pulled off. This line here shows the line of the plinth approximately, and this dotted line across the top, which is effectively the crest of the dam. So if you sort of look down, you can sort of imagine the crest of the dam coming across here, and then the upstream side being in here, and the downstream side being over this side. So you can see we're sort of making good progress clearing back the overburden and getting ready to work off the rock. This is on the same side, the left-hand side, but preparing for the plinth. So you can see the photo on the left. This is the top. This is effectively the top of the dam, and this is where the plinth starts from. And so the plinth will be will be constructed down here. This is the same shot, looking at the rocks. This rock's been tidied up, almost ready for concrete to be poured on top of it. So the guys are just days away now from pouring concrete here and sealing this. We're ready for the plinth. And the plinth really runs down the whole face here. So you can see that we're pretty happy with the rock we're finding here, which the foundation of the dam is ready to be built on.
Amy, can you turn those lights off there so we can get a better...
Absolutely.
better?
We'll keep you on.
But how are you anchoring the concrete into the rock face? You're drilling in and putting in?
Yeah, look, I might get Peter to give you a bit of an update on that, because I was waiting for that question around what is a plinth, because I've been talking about a plinth for the last 5 minutes, and you're probably thinking, what's he talking about? So if you just go to the next slide, Amy. So that's the same photo again. Here's the plinth, and it's going to be sort of layered down. It's going to be constructed down that face there. Peter, do you want to perhaps give us an overview of what a plinth does?
Sure. Maybe I'll look up on the point. So this is the rock shown here. This is this concrete face coming from the top all the way down, and this is where it's basically just joining the rock. So a triangle of reinforced concrete with a slab here to make it a larger space to work on. And you can see there's, at least in this location, 3 big steel bars anchored into the ground. So the principle being that it's well and truly hooked into the ground. There's a massive reinforcing in here, knitting the whole thing together. And then there's what are called water stops, which are like rubber strips to prevent the reservoirs up here, prevent the reservoir, minimise the amount of leakage. So the idea being, this is excavated, the piece of concrete that Mike was just talking about gets placed just to level everything up. Then the reinforcing, well, the holes are drilled, reinforcing cage, and then the grout curtain is drilled through here. So the grout curtain is multiple holes drilled. They're shown here nice and vertical just to help show you what they are, but they sort of operate in an angled fashion, to the idea being that you drill the hole and then you pump cement grout, so water and cement, and that fills any leakage paths. So you're just trying to seal up the ground. The principle being that if the reservoir can't get through here, it'll try and get through under here. So you're just forming a bigger barrier, and you're using the rock and knitting the rock together, really. But the reason for doing the grouting is predominantly to stop the leakage or reduce the leakage. So,
Yeah. So this cross section here sort of runs down this face here, right across the toe of the dam, right down one side of the valley, across the river and up the other side. So this is now looking at the other side, which is the right-hand side abutment, and so similar story. It's as expected. Good progress. You can see here. You can see here that the guys have pulled back the overburden, and this piece of top rock is good quality, happy rock that we're very pleased with, and that's really now ready to actually have the dam built on top of it. So it's getting close to being certified. And over here now, this is a bit of an old photo, but Matt and the guys are actually sort of pulling this back now to start the anchoring and the stabilisation of anchor above the reservoir. And then they'll come down and keep clearing the overburden off to expose us ready for the embankment. So this is essentially the foundation. So good quality rock as expected. I couldn't resist drawing a few more lines. So this is effectively the same photo, aerial photo showing how the pulling down the overburden. I've just put a couple of lines on here. The black line is where the plinth on the right hand side will more or less go. Dan tells me it's not quite a straight line, but close enough. So the plinth comes down. This is what Peter was just talking about a minute or two ago. It comes down the side here. They're now actually sort of clearing for this, for the top of the plinth. What the red line shows at the bottom is the culvert that will be constructed shortly. The culvert is a large concrete structure. It's basically a large conduit. It's 160 metres long. I think it's 8 metres wide by 6 metres high, isn't it, Justin?
That's right.
Yeah. And the culvert will be used to flow the water through. So very short. Once the culvert's built, the guys will build coffer dams to divert the water into the culvert, and then once the water's flowing through the culvert, they can start building the dam above the culvert. And it's a bit of an old photo because I think, Matt, correct me if I'm wrong here, but you guys actually started excavating for the culvert already, haven't you?
We've got the start on the lower end here, and then the stripping of that buttons a lot lower than that.
Yeah, so you come further down, haven't you? So this is another photo of rock, just to really convince you that there's good rock up there. So this is the abutment. This is the same angle. It's basically standing on top, looking down the abutment, and you can see that this we're pretty happy with this rock. It's like as expected. They've cleaned it off, and you can see they've actually now sort of laid out some of the grids to survey it and now certify the abutment rock. So that's pretty much where we're at. A lot of progress that Ford and Hogan Taylors have made over the last month. It's really pleasing to see that those abutments get cleared so quickly, and we're feeling very pleased with the quality of the rock so far. Look, it's early days, but touch wood. It continues that way. If we look forward now, over the balance of the year, clearly getting the abutments cleared is the priority. That'll happen. They've started work already on the rock anchors and the slope stabilisation. It's anchors, mesh, shotcrete to stabilise the banks around the reservoir and above the plinths. Commence forming the plinths on both sides. You saw how close we are to actually getting ready to put some concrete down. Peter and Matt will be getting into the river pretty soon. As I said before, diverting the river to the left-hand side of some diversion bunds to allow the culvert and excavation to happen, and then getting ready for the culvert construction really. And in the meantime, we keep clearing the vegetation. So it's going to be a busy period through to the new year. I think Ian showed you this photo before. It's an old photo. It shows the site with a overlay of what the dam looks like where it sits with the spillway there, and that's just an aerial photo showing the layout of the dam on the site. So,
Where are you drawing the water off?
where are we drawing the water off?
What part of the dam has the water been drawn off from?
Oh, yeah, okay, good question. So, so the culvert, I described the culvert before.
Yeah.
So this is the water runs through the culvert while we build up around in the river above the dam. And then when the dam's finished, or close to finished, we put the offtakes down the side. There's two offtakes down the face of the dam, one down really low and one down up a bit higher, so you can control the temperature of the water. And these offtakes, these pipes, come down the face here, and then they run through this culvert. So the pipes run through the culvert, and then we have nozzles at the far end which disperse the water. So to answer your question, offtakes are here, come down here through the culvert, and the water gets released just back here. And I know a lot of people are interested in the potential for hydro. That's where you basically click on the hydro power later if the TDC decide to go that way. On the environmental front, we're on top of our resource consent conditions. Alistair keeps a good handle on the conditions. We're working 98 action items at the moment. We also have a biodiversity management plan that we're working with the Biodiversity Technical Advisory Committee. On site, most of our plans are now in place and are working well and being monitored. The water quality has been very good so far. We have continuous turbidity monitors monitoring the water quality, and we have fortnightly guys go out to site and measure the water quality. So that's going. We've relocated some of the rare species from the reservoir that we need to relocate. The 4 sediment ponds are up and running, as you saw before in the photo earlier, and the decanting bunds are operating. And off-site, we've just ordered 10,000 plants to commence planting at Rough Island next year as part of our environmental project. Program, look, as you can see there, the red shows the critical path, and you can see they're having sort of basically slid by 2 months, and that really comes down to just a late mobilisation. We had a late start, as I said earlier on. Rather than start mid-January, we started middle of March. We had some, as you know, we had a drought with fire restrictions, so we really couldn't do much for 2 months. Let's go to the next slide, Amy. So, costs. I know you all want to know about the cost of the project. So the graph on the left-hand side shows where the money is coming from and where the money is going to. So the green shows the money that's coming from the irrigators. So you can see the Waimea irrigators are providing $20 odd million of capital and another $20 million of loans. So it's about half the money. The blues show the TDC money, so you can see in the dark blue sort of the 30% that the ratepayers put into the project, and then the lighter blues are where the TDC is getting grants from the central government, Western City Council, and a loan from the Crown as well. And there's a little bit of investment income as well at the top. And you can see on the right hand side that obviously most of the money is paying our good contractors to build the project for us, and we have a small overhead of the project office, as well as the pre-construction spend on the ECI process and buying the land, getting the design done, getting the consents in place.
As a proportion of the ratepayer contribution, what percentage of the total?
So the dark blue bar there, and I know Mike's in the crowd here, he's going to pull me up if it's wrong. So the dark blue bar, so the ratepayers put in about $30 million of ratepayer money now. So 30 out of 104, about 30% thereabouts. And then the rest of the ratepayer equity comes from the Ministry for Environment and from Nelson City Council, and also from a loan from the Crown.
Any provision for cost overrun?
There's funding for cost overruns, yep. So, and there's a question, we'll come back to this later, but I'll answer it now. So, the project funding agreement has another $3 million of overrun, basically paid 49.51, in line with the equity contribution. So the project has a funding agreement to provide a bit of cost overrun. The graph on the right shows the spend. There's no news here really. The grey bar is where we thought we were going to be. I said before we're 2 months behind, so the red line's 2 months behind the grey line. But at the moment we have no reason not to believe that we're not heading towards 104.4 million, which is the approved budget. Just to give you some context on risk, so a lot of folk ask what the risk is in the project and how much can money costs increase. So about 22% of our project budget is at risk, and that's really around the geology. So 78% of the project is fixed lump sum costs, where Fulton Hogan and Taylors provide us with a fixed price for a lot of the work. So the risk is about 22%, and that's really around the geology, the rock, the grout curtain, and the M&E, the mechanical and electrical, is still being designed. Performance on safety. Look, I think I can speak for Justin and Matt, but our biggest concern and what we worry about the most is that no one gets hurt in this project. So we put a huge effort into safety, or at least these guys do. And so far, no one's been injured, and touch wood, that continues. We've been out inside and we've observed safety performance, and as you can see there by the bars on the graph, there's a lot of green in there, so we're pretty happy with the way that the safety's been managed on site. On the right hand side, as you can see, with our compliance and auditing, we're on top of our resource consent conditions, 65 of them in rate order. We've finished 25 of them, and there's 8 which are coming out and we're sort of on top of as well. But we have no non-compliant or late issues. So, and just while I'm on the subject of compliance and audit, I will say we just got our audit opinion, our good audit opinion from Audit New Zealand, and they reviewed and we're happy with our accounts and our annual report. So that's really all I've got. Just a last slide here, a bit of a pitch. More information. If you want to know more about the project, please go to our website or our Facebook page. Leanne's just updated our website, so it's got a bit of a fresh look. This is the front page of the website here, so www.waimeawater.nz, and you can see here that we'll put online construction updates, latest photos, news, recent events, and we've just published our annual report. So if anyone wants to see how we got on in the last financial year, I'd encourage you to go and read our annual report, which is available now. So thank you. That's all the team and I had really on providing an update. So we'd like to now swing to a Q&A session.
The lights back on.
Yeah. So I've got Justin here. We'll answer some questions on the progress of construction. Peter, some technical questions. Ian as well, and not anything else. So I won't call out names as to who asked the questions, but thank you for the questions. So the first question we had is, I've read that the dam design would not cope with severe earthquake. Please provide details of how resistant to seismic damage the dam will be. How will the dam behave in an earthquake? So, Peter.
Okay. So the principle of the dam is that the concrete face is there to hold the reservoir. The large amount of rock fill is there to support that face. It has that other function of so firstly, supporting the face is all about the rock materials that are used and the quality of construction effort, so that the large amount of rock fill supports that face. It doesn't settle. In an earthquake, it will be shaken. You'll appreciate that. That shaking will undoubtedly involve a little bit of, there'll be some settlement, but the better the quality of construction, the better supported that concrete face is. That concrete face may well have some cracks and so on. It's concrete. We know that sort of thing can happen. So the idea of the materials that Ian showed you inside the dam, that they the first layer is controlling the amount of water that could leak through, and then everything behind it is draining it. So it is like a backline defence. So the ideal is that the dam will settle a bit, the concrete will not crack significantly, but where water does get through, that these zones of rock are basically controlling the amount of water that can come out. So and this is the fundamental principle behind how these have been designed and built for tens of years. So that's the way it's expected to perform. It's been designed for the very large earthquake that Mike talked about, which was from the faults about 8-10 kilometres away. So the science advice from GNS about how much shaking that would then induce at the site. So they provided the science saying the earthquake occurred 10 kilometres away, the amount of shaking at the site, which Ian put up there and told you in terms of percentage of of the force of gravity. It's basically a force, and so applies that amount of shaking to the dam, and so the dam has been then designed with that in mind, or that put into the analysis to determine, to demonstrate that it's going to perform as I've described. So there's been quite a lot of, firstly, science providing a really a really good level of quality of science about how much the ground would shake in the very worst event, and then comparing that to how the structure should perform when shaken. What is that? People.
Could I just ask one question? Peter, is there a peer review done of that design as well? So someone designs it and then someone checks it? Is that the process?
Yes. The process to get to the stage before construction was that that design was peer reviewed by a completely independent group, and both of them submitted to the council, in effect, their certificates to say that that had occurred. And anything that we are doing now in the construction phase that might lead to change goes through a similar process. So Waimea Water has a separate group of experts who validate what we do.
So those signatures from the company that did the peer review, or an individual professional chartered engineer who gave his approval to the whole project, which one would interpret as assuming liability for anything that goes wrong in the future.
Yes, the certificates are signed by individuals with professional engineering qualifications. The company is supporting them in producing those certificates, but those individuals are, as you say, in effect putting their own professional credibility on the line by signing those certificates.
The rock under where the dam's been built, has it had any seismic uplifting at all over millions of years of being there?
Oh yes, as has the whole of New Zealand.
So it's a fault in its own.
There's no fault. The active fault is identified as 10 kilometres away. We haven't found any faults, as in tectonic features that move when the centre of the earth moves, in the valley. And that's sort of how New Zealand's built. There's faults places, and the ground in between has been shaken over tens of millions of years. And that's caused mountains to come up and mountains to come down, and all of those processes. So here, yes, the rock has suffered through tens of millions of years of alpine fault movement, the nearby fault moving, other faults nearby and so on. So the rock has, but it's largely a mountain building process, so it's been sort of lifted up the sea, and it's been driven down sort of through these events. So the rock is pushed and squeezed and bent a bit, but it's pretty much like the rest of New Zealand.
So there's no chance of the dam leaking further up with the amount of water that's behind it?
Leaking into rock underneath the dam?
Yeah.
Oh, the process of mountain building creates joints in the rock. So the water seeping through into the country is all going through these joints and rock. The principle of the grout curtain and that sort of thing is to lock it up in a sort of a line, forming a barrier under the dam.
So how deep down is that going to go, the ground?
Oh, that goes about 30 metres below the ground.
Okay.
So it's quite substantial work. It's a big item of the cost. It's recognised. This rock here, which is very common to the Southern Alps, in our experience, doesn't leak a lot. That's a funny thing to say. If you're in the North Island where there's big volcanoes, there's all sorts of volcanic features that lead to large leaks, and they are much more challenging to stop. This is quite sort of modest in the scale of things, I suppose. There will be some, the grout will go into the ground. It will find its way through various joints and so on. But the fundamental purpose of that curtain is to provide that barrier.
Whose responsibility is it if the reservoir bowl actually leaks and the reservoir fails to fill properly?
That's interesting. That's an interesting point. In this sort of rock geology, that's a very unlikely thing to happen in the exploration of the design process over the years leading up. Didn't identify anything geological that would be a telltale for something like that. The sort of country where that happens is limestone country. We have big solution cavities, so Takaka Hill sort of limestone caves and so on. But we don't have that in this valley. And there's again volcanic sort of terrain where you get lava tubes and things like that. Those are much more difficult to solve that problem. But the team who did that exploration work here looked for things, but couldn't identify anything that would give them the concern you're talking about.
And the ground that we've exposed so far is pretty tight, isn't it?
Yeah.
The Waimea Water Limited assuming responsibility for the reservoir bowl to hold water.
I would say, fundamentally it's the economic principle behind the project that it will successfully do that.
Do they have insurance for that sort of thing? Repaid?
Yeah, so that's, we're insurance for the dam, the performance of the reservoir. We fully expect the reservoir to hold its contents, and in fact you can't see why it won't. And it's obviously topped up all the time by rainfall. It's a great catchment. I think during the month of June, from memory, we could have filled the 10 out of the 13 million cubic metres in 1 month alone. So, the next question that was asked of us is what evidence is there that the planned release of water to the river will effectively and efficiently replenish the aquifers? Could you have water being lost to the sea? So it's a common question. The good news is we have a prototype. There's a prototype working. The Waimea Dam was commissioned in 2006. It was built with a larger dam in mind, and it's pretty much behaved exactly as anticipated by feeding water to the river, and it was frankly instrumental to helping folk out during this last drought. The migration of released water has been modelled by GNS, NIWA, DSIR, Tonkin Taylor, and various experts, various qualified, professional, experienced, reputable experts who then had their work peer reviewed by others. Right? So it's been through a lot of eyes. On top of that, we went through a planning process and then a resource consent process a few years back, and so it's been reviewed many times. And the scientists and the engineers are comfortable with the science. My understanding is that the released water from the dam will travel down the Lee River into the Wairau river, and about a kilometre downstream of where it joins, it basically starts recharging the aquifer through the gravels. And of course what that really does is it increases the piezometric gradient. It puts some head to pressure on the aquifer, which increases flow into the bores downstream, which are providing the reticulated water to Richmond and to irrigators. Look, some water will go into the sea. Part of the merit of this project is the environmental benefits to the river. So in those dry, droughty months during summer, when the river low drops right down, we'll keep some water flowing, so it maintains the environmental. It doesn't damage the environment, and it supports the ecology. And that's why the Ministry for the Environment is providing some money. Right? It's for that exact reason, to have water flowing down the river. And if it's flowing down the river, by definition, it ends up in the sea. But that's all part of the modelling. Next question was, should the economics be favourable after the dam has been built? Does the design provide for the future hydroelectric generation? That's a great question, right? You've got 50 metres of head almost for free. So why wouldn't you look at hydropower? And the answer is yes. So we're designing the mechanical and electrical in a way we can bolt on hydropower later. It's going to be it's not what Waimea Water Limited does. It's what the TDC will do. And the TDC are currently looking at that now. They're using the same engineering consultants for the M&E work, so it's been looked at pretty hard, and it will be compatible.
That was my question, it was answered earlier, so I don't know another one. I'd like to know what's been done with all the other burden that's been stripped off. You mentioned where that's going.
Yeah, a lot of it's going into the floor of the dam profile. So there's about 10% of it, the bottom intake, if you like, is above that. So we're filling in that piece of the bottom of the dam.
The other one, one of the items of scuttlebutt during the rounds is that suspended sediment from the adjoining land use is likely to have an effect on the aquifers. Is there any merit in that?
So, sorry, if I understand the question, sediment runoff has...
suspended sediment as a result of adjoining land use,
Yep.
Ending up in waterways, is clogging the aquifers, thereby negating the potential for them to be recharged.
Well, I haven't heard that, and I'm not quite sure how I can see it working. So downstream of the dam is really the TDC's responsibility, and they've put some science and modelling into this. So I'll be pretty confident that they've done their work and they wouldn't. I find by the time the water gets there, I find it pretty hard to imagine how there can be any sediment in the water.
It seems a little far-fetched.
Yeah.
If I could just add one thing to that, looking at it in a geological sense, there's been tens, hundreds of thousands of years of that river running down across the plains, delivering sediment, and that hasn't occurred to date. Admittedly, there is accelerated sedimentation now. If you look at the context of the whole time, that very long time hasn't blocked up the aquifers.
Good point. Yeah, thank you. Yeah, good. So the next question we have is progress. How is progress, and are we happy about it? So pass it to Justin.
Yep, Mike, it's great to be here tonight, by the way. It's suddenly got a bit warmer in here. Definitely warmer than outside anyway. No, it's great to be here on behalf of Fort Hogan Taylors. Yeah, the progress has been really good so far, as Mike alluded to. We had a bit of a delayed start at the front end of the program, but we're certainly looking at ways we can change the program to try and claw that time back. We've got about 50 people on site at the moment, and we've done about 70,000 man hours. So Mike spoke about our primary concern for our people up there is health and safety, and we're putting a huge focus in there to make sure that our guys and girls are safe while they're working out there. As you know, she's pretty steep country in that small valley, and yeah, we're really concerned about the safety of everyone that goes up into that valley, make sure that they go home in one piece. Yeah, so we've started on the left-hand side. We've taken it back to the competent rock, and we're, as Mike said before, we're about to start pouring our first piece of the plinth, and most of the vegetation has been pulled off. I think one of the questions we've got coming later is what happens to all the trees. So a lot of the trees have been logged and been taken out off-site, and the native trees have been put into a lot where the local iwi will take those trees away, and there's remus and ratas and those sort of trees in there. And a lot of the slash will be, well, most of the slash will be milled up and mulched and put on the floor of the dam. And over time it will start to degrade, and then we'll disperse it through away from the dam profile up into the forest areas. Yeah, so the road into the dam's almost finished now. There's a lot of work's gone into the design there. There's a couple of tricky slips that we've had to control, and on the right hand side we've started drilling, which is good to see. So yeah, there's a couple of drilling rigs in there flat out putting the ground anchors in that Mike spoke about before. That's about it.
So pretty happy.
Yep, that's good.
I am anyway. The second part of the question is around the foundation work. So, have any issues arisen regarding the foundation work? So, Peter, you've been on the site today. What do you think about the foundation?
Well, I think Mike showed you some photos before. So the taking the trees off and having a good look at the rock, it's as expected, I suppose you could say. It's, as we talked about just on the previous question, yeah, the ground has been moved over tens of millions of years, so there's loose material to clean off, and then there's pretty good rock on the profile that has been expected. There's opportunity now that we've got the ground open to tidy up some of the loose details. So all in all, it's as good as the investigation had portrayed it, I suppose. In terms of the surface that's being exposed that we're going to build the structure on.
Thank you. There's a number of questions around money. So the question is, who pays the cost overrun? And as I said before, the projects currently has a budget of 104.4. The funding agreement takes us to 107.4, so there's an extra $3 million there, which is not in the budget, but it's funded. And that's met 49.51 by equity between the TDC and the Waimea Irrigators Limited, and then past 107.4, it's currently with TDC. So there's a question around could there be cost blowouts? It's a civil engineering project. There's always risk in civil engineering projects. We have de-risked a lot of the project. Contractors taking a lot of risk on themselves. 78% of the project is a fixed price, so they probably have more risk than we have. We have contingency, which was calculated based on a reasonable basis of what cost overruns may be. And I think it's fair to say that we'll have a better view on the geology sort of midway through next year. There's another question here, Peter, about it's on the Alpine Fault. So if there's an earthquake on the Alpine Fault, could it damage the dam?
Sure. The Alpine, I mean, if people are aware, the Alpine Fault, the nearest to here is Sanana. Goes through Sanana. If you own a holiday house in Sanana, you should be more concerned about that, I'm afraid. So you understand the distance from here to Sanana. The faults that we talked about earlier, which GNS identified as being the closest, more likely to drive the largest amount of shaking, were 10 kilometres away. So the difference being the energy from earthquakes, as you will appreciate, dissipates as you get further from the fault. So GNS did quite a lot of research. They plug into their research the Alpine Fault, sort of Sanana intervened, that was affecting Sanana. They plug in the nearby fault 10 kilometres away, and work out which is the dominant shaker, I suppose. And they provide that information to us and their recommendation about which one to take as the dominant case. What they're talking about with the ones nearby, they're providing a period of shaking to us of about 90 seconds. So strong shaking for a long period of time from the nearby fault. The Alpine Fault is further away and has lost energy before it gets here. It might shake for a bit longer, but the scientists' view of which is the strongest and most likely to understand was the more local fault. So yes, we'll all feel it when the Alpine Fault goes, absolutely, but it's not as intense as the nearby action. Right.
Okay, thank you. Very good. Here's a question for you again. So one of the questions is there's been talk or concern that the cost of decommissioning the dam in 100 years' time will be $100 million. And if we factor that into the economics, I've got to say 100 years is a little bit beyond my time span, but Ian, perhaps you can comment on decommissioning dams.
It is quite an interesting question actually, because it does pop up from time to time. Decommissioning a dam is a pretty complicated and probably quite expensive exercise. There probably aren't that many reasons why you would do so. These structures provide sort of almost perpetual economic benefit to the region. In this case here, it's shoring up the local water supply and irrigation supply. And it's also probably a bit unfair to try to estimate what that cost in the future may be. I don't know if there's any real answer to that, other than I'd have to reevaluate in 100 years' time.
But I don't know if you guys noted on the first slide Ian put up, but that dam in Palmerston North, the concrete based rockfill dam, same construction, 1907, right? So and they upgraded it, and they did the last upgrade in the 90s, wasn't it?
Yeah.
So it's gone past 100 years, and
Still supplying water to Palmerston North.
Yeah. You tasted Palmerston North's water recently? Need one of Julian's ice creams to get over it. Ma'am, sorry.
At what cost was the upgrading? And who's responsible for that?
For the dam in Palmerston North,
Yes.
I'm sorry, I don't know.
Oh, I think at the time it was upgraded by, as the city council owns the dam. It's for water supply for Palmerston City. My understanding is that, well, as the owner, the operator, they have, obviously it's valuable to them because their ratepayers want water, but secondly, they have an obligation as an owner to maintain it to the highest standards. So part of that ownership obligation was periodic review and identification of deterioration. In that case, it was deterioration. In other cases, it might be that something designed in 1907 hasn't got the science of today's design. So there's periodic reviews may bring to the surface, or just bring out there's modern lessons to be applied, and these this if a structure has got something element that's not wouldn't stand up to modern practice, then it comes back to an obligation on the owner to do something about it.
And the same thing with Waimea.
I would expect so. In fact, the government, this government, is looking at enacting law change or introducing a law that would, in effect, make it directly an obligation of the owner. Currently, it's not encapsulated in a specific law, so it's other laws that kind of drive behaviour. It's a little bit. It's good fodder for lawyers, but if the government does enact new law, it'll be very clear what Waimea's Water, as the operator, will have to do, and it will be, I'm sure, quite rigorously enforced.
So the next question we have here is, there have been 2 drilling rigs for 6 weeks and they haven't found bedrock. Is it true or another incorrect rumour? It is not true. Right, it is rumour, and I'm going to call it out. It's fake news and fearmongering. Sorry, there's no other way to dress it up. It is incorrect. We're happy with the geology. It's as we expected, and we have not had drilling crews in for 6 weeks looking for rock. So the second part of the question is, well, if you don't find rock, or if the rock's not like you think it is, there are other ways to anchor. I think the more important question here is the anchoring piece of it. And so, I mean, anchoring is really key here for a number of reasons. So I'll get one of our dam experts, Peter, maybe you can just talk about why we anchor the plinth, why we anchor the spillway, start of dam. Particularly the spillway, right?
Yeah, so again, we showed you the plinth before, so you get an idea of the sort of things that we're doing with the plinth. And that's basically to bind it all together, prevent leakage. With the spillway, Ian mentioned it before, that they had a couple of, in the last 3 years, a couple of very, some bad incidents, and one in the United States and California and one in the UK in the last couple of months, where similar sort of structure, water got underneath the concrete because the details of how all the concrete elements are put together was old technology, let's call it, just from a time when people didn't really understand quite what they were doing, and made some. Well, we've learned from what they did, what happened with them, and so. One of the ways to be sure it doesn't happen is to put the same sort of anchors under the slab of the spillway, and so that's part of this design. So every single slab will have multiple steel rods grouted into the ground, connecting them to the ground. That's the basic design principle. And the examples that didn't work so well was where they firstly didn't understand whether the material underneath was strong enough, and they didn't connect them well enough, and they also didn't put in drainage to any water that got in was whisked away by the drain, and that wasn't done very well either. So there's sort of 3 elements to their lessons, all of which are part of this design.
What diameter are the rods that you're putting down?
Either, well, in effect, 25 millimetres or 1 inch, or 32 millimetres, so 1.25 inch sort of size. About 4 metres long, so quite a lot of steel in the ground, routed into a hole with grout that's as strong as concrete. So it's, but this is deliberate because when it starts to if it ever was to get into a situation like the one in America, you've got enough grunt and all that steel, concrete grout to keep it all together.
So you're going to drill these holes down, what, 30 metres?
No, sorry, not these ones. These anchors are only about 4 to 5, 6 metres long.
Right. So your plinth ones are going to go down 30 metres?
No, sorry, the plinth one, the rods only go about 6 metres.
Okay.
The holes for the grout to seal up the ground, they're the ones that go to 30 metres.
What diameter will they be?
Oh, the hole itself is about 80 millimetres, so 3/4 of an inch. That's sort of 3 inches. Sorry.
No 25mm reinforcement blocks?
No, straight grout pressurised into the cracks.
Yes.
Grout only?
Yeah. So the idea of that is that you push the grout into the cracks.
Yeah.
So it's all under pressure, whereas the anchors are about connecting the rock to the concrete.
Thank you, Peter. Next question was, please explain why the dam was promoted by the TDC to offer a reticulated supply within Richmond and parts of Tasman. This is a little bit outside my remit. Really, what the TDC promotes, you should probably sort of talk to the TDC about. But having said that, I'll take a stab at it anyway. Look, it comes back to what I said earlier about putting recharging the aquifer, putting more pressure in the aquifer, a greater piezometric gradient. Darcy's law means greater flow to the wells, so the wells that currently provide the water to the reticulated supply will have more flow. That's the logic. Right. Some more questions. So I have a question here. Can you please clearly state the current estimated total build cost, excluding the sunk cost to date? Let me answer that question, but turn it around slightly. So the current approved budget, which we have no reason to doubt at the moment, is 104.4. That's not breaking news, you should all know that. Of that, 8.2 million was spent prior to financial close on things like land and design and consents. We paid the insurance bill, that's $1 million. The ECI process with the contractor was $1 million. So 104.4 and the sunk costs are about 8.2 million. Can you please state the accrued spend from financial close to 31st of August? 24.5 million is the answer. But again, I'll please appreciate that of that 24.5 million, 8.2 was spent before financial close. Can you please state the percentage of work by value completed to date? Should I ask you this one, Justin? I'd like to know the answer to that too.
What was the question, sir?
Can you please state the percentage of work by value completed to today? Was to 31st of August, sorry. Justin can answer that in a second, but let me just give you some numbers first. So as of the 31st of August, we have paid the contractor 11.7 million out of their 78.7 million. So 1 divided by the other gives you about 15%. In that payment of 11.7 so far, we paid for a lump sum payment for the flood risk because they had to lift a big flat side and do a whole bunch of work, and that's about 2.8. So if we back that out, it's about 12% is what we've paid the contractor so far. So, does it feel right, Justin?
Bang on, what? Yeah, well done.
I'm sure you guys have actually done more than that, right?
Pardon?
Aren't you meant to say you've done more than that?
Absolutely.
That's what Matt said.
I've got to watch it. My chairman's sitting right there, so.
Can you please clarify whether or not the following items are included in the estimated total build cost? Firstly, an emergency spillway is recommended in the NZ solid guidelines for all embankment dams. Ian, that's yours.
Short answer is yes, we do have an emergency spill one, which you can actually see on that photo on the right hand side of the board there. So that spill one itself has been designed to sort of pass the highest possible flood, the flood through the structure. So I think, short answer is yes.
Have we included in the current estimated total build cost the drilling and blasting costs for the highest classes of rock?
Yeah, the answer to that is yes. So when you have a high class rock, of course it's harder. So we've got to mine it by drilling and blasting. So we've allowed for that a quantity within our build cost, and that will be measurable as we go through the project.
Nice. This next one too, Justin. So have we allowed, and how are we removing the material of vegetable origin from the complete reservoir basin and the safe disposal of material?
Yep. So I mentioned before, about 2/3 of the trees that are in the basin itself are large diameter trees, large enough to log, or we keep them for to give to the local iwi, Ngāti Koata. I can never say that properly. Pardon?
Ngāti Koata.
No, Ngāti Koata, thank you. And then the rest of the slash is effectively milled, so Matt's got a big milling machine that mulches the material. That's laid out in the base of the...
mainly on the hill around, we haven't got much of the waste, we use it for environmental controls of the dam.
Yep.
And we spread it around the adjoining land to stabilise the headland runoff into the dam.
So if you drove down the site, you'd see it on the side of the banks to stop any rainwater effectively turning into mud and going into the river.
Big mulch,
Yep.
big mulch.
That's right. Yeah. How many tonne an hour, Matt?
200 tonne an hour.
200 tonnes an hour.
Okay. The next question was, have we settled all outstanding issues regarding the purchase of land, lease of land, settled disputes with the affected landowners? I guess the short answer is all the land's been procured, and most of the issues have been settled, and we're just sort of closing out and tidying up some of the last issues now, but it's basically administrative. There's nothing untoward or no unresolved issues. Have we acquired enough the acquisition of purchase of cutting rights to the forests on the slopes around the reservoir to reduce the risk of slips into the reservoir if those forests are cleared? Once again, Waimea Water Limited has procured land around the reservoir, parts of the reservoir, so we can manage the vegetation, the trees around it, and obviously manage the slope stability as well. The provision of facilities for hydropower we talked about, so TDC got that in hand. Stabilisation of slips upstream of the dam, this is a good question, this one. You clearly slope stability upstream of the dam around the reservoirs is pretty important, as I think we all know from around New Zealand. So Ian, do you want to take this one?
Oh, yes, sorry, the question was around slope stability.
Yeah, what are we doing about stabilising slopes around the reservoir?
Yeah, so there's a fairly significant budget allowed for stabilising some rock bolts and shotcreting some of those slopes around the reservoir. There's also a few sort of historical cases with impoundments triggering some landslides and things further up in catchments. So one of the activities that we'll be doing as the trees are cleared is going around to sort of inspect for those landslides and treat those as we need to.
And Justin said before that we're already doing it, right? We're looking at now, we're drilling a hole, move the anchors around the slope above the reservoir upstream of the right end abutment. Grouting any fissures in the reservoir basin to reduce leakage. I think we had that question before, but maybe you can take a crack at this one again.
Oh yeah, so Peter mentioned before we've got some rails 30 metre deep grout holes around the base of the dam, which are primarily intended to stop any seepage water from the reservoir sort of flowing beneath the dam and being lost in the system essentially.
Have we made for the provision of new access roads and bridges for landowners and forestry operators whose access roads will be inundated when the reservoir is filled? Yes, we have. We've already cut some of those in. Matt and his guys have done that already, and we will make new roads, and that's all by agreement with the landowners, so they're pretty happy with the new roads and bridges they're going to get access to. And then the final question is, have we allowed for a fail-safe evacuation alarm system for Brightwater? Ian, do you want to talk about the emergency action plan?
Yeah, so safety of the public is probably the primary concern for any dam owner, and certainly something we take quite seriously. So there's been an emergency action plan developed for the dam already, which is currently sitting in draft form, and as we work through the project, we'll refine that and develop it. Primarily that's the emergency response, which will be implemented, will be using the police and civil defence to actually carry out an evacuation of Brightwater if that was required. But having said that, there are plenty of steps which would occur prior to that through some routine maintenance and surveillance and the day-to-day operations of the dam, which would help you prevent anything serious occurring, which would require evacuation.
So we'll take the answer to that question as well. Nobody is allowed for a fail-safe alarm system for the residents of Brightwater.
Not an alarm system, no.
No, it wasn't required in the...
Yeah, I know that. The answer is no.
Okay, so that's all the questions we've got submitted to us. We sort of have 6 minutes left. So if there's any further questions, I'd like to hear them.
Are there any dams that have been? Are there any rivers that have been benefited from being dammed?
Are there any rivers
that have benefited from being dammed in the headwaters?
What, you mean any dam?
Yeah, just any dam around the water side.
Well,
Because usually it degrades the river. That's why I asked.
yeah, but I don't know the answer. I understand the Waimea dam flows more regularly now. The Waimea River, the Waimea dam flows more regularly and supports environmental flow, so sustained ecology.
Well, I think it's one of the challenges with dams that that there's a trade-off between the dam is certainly impacting because it's in the middle of the river and forming the reservoir. There's been some examples where the river's benefited, as Mike said, because of regulation of flow and environmental effects on the river downstream, where they used to dry up and so on. Benefits around the feeding of the aquifers here. There's the part of this design has a fish passage and so on in it, so that it's intended not to minimise significantly improve the opportunity for fish life. So they come with benefits and challenges, and I think that's appreciated so much more now than it was 50 or 100 years ago. The examples from that time where those appreciations and mitigating measures in place, certainly those examples aren't as good as what people are trying to do today.
I've got two questions. One, the thickness of the concrete across the face of the dam, and the second one is there any allowance if there's build-up of gravel upstream of the dam to remove that build-up of gravel in a future time if it's going to start causing problems?
How thick's the slab?
So the slab is 300 kilos thick, about that thick.
Right across.
And the intake, the outlet works have been set at a level so that any sedimentation which comes from the dam won't affect the ability to release water. So there's actually allowance within the reservoir below that bottom intake for 100 years worth of sediment, which is about 1 million cubic metres.
Yeah, just relying on my memory, in the original design, the diversion culvert was 20 square metres cross-section area. Now it's 6 by 8, 48. So am I correct in assuming the diversion culvert's been upsized by about a factor of 2?
Or was it actually 2 culverts?
It's two, yeah, so it's a twin barrel.
Yeah.
Yeah, I don't recall the exact dimensions.
Mike said 6 by 8, somebody said 6 by 8.
But your question is has the
Has
size
it been up?
only...
Yeah, my recollection of that has
Yeah.
been upsized.
So in the east, in the east side process, there was significant work done on river diversion, river flows, and that is the contractor's risk. Yes, we had upsides the Colton Home with exactly as you
Okay,
said.
to reduce the flooding risk.
To reduce flooding risk, yeah. There was a lot of work done on how we deal with.
So I was considered.
Thanks, mate.
Will we be able to go up and do boating up there and fishing and kayaking and things like that?
Yeah, that's what my son asked me.
I like the Clyde Dam, you can go
It was
boating on that.
There was a
Fishing.
public access requirement in the Act that got passed, so I'd be interested in hearing a bit more about that. Yeah, look, at the moment, no. I mean, it's obviously a construction site, and it's private land that the roads go over. And we have pretty restricted uses. I mean, I'd imagine, well, it's a matter for the TDC to contemplate.
I think Nick Smith told us he would make sure it happens, so.
That was one of the conditions in the Act. Conditions in the Act, so.
Yeah, especially.
You know, I'm a member of a local tramping club, and I'm sure there's 1 or 2 others here. Admittedly, the Lee Valley is not a very popular access route to Richmond Forest Park, but there was a provision for public access in the Act, and I'd be very interested to hear how that is going to happen in the future. So, what's with the TDC? Can I say something, Mike? Sorry.
Kia ora, Mike Ramadai, work for Council. Council will be looking at that public access in the new triennium. And so at the current arrangements for access don't permit public access to the dam site. Council is aware of the provision that was in the legislation, and they'll be considering how they might give effect to that. And that'll be a decision for the Council in the next triennium.
It shouldn't be a consideration, it's in the Act. It's a public access requirement in the Act for the land. There's no consideration required.
I think there's a... Technically, Councillor Mailing is correct, you can walk up the river. However, I think Council's probably going to look at what the level of access will be and how that might occur. That is still a matter that Council will need to determine. It's not a matter for Waimea Water Limited.
Thank you.
I can comment, you can currently walk up the river now, but it's got to be light. And I do it regularly because I'm a trout fisherman, and there's not many trout in that river up there, but I won't tell you where they are.
So I've been caught by the drill guys.
No, it's a lot further up than there, but it's got to be low water to be able to walk up there because the gorge is pretty difficult to get through.
All right, any
Justin, can I ask Justin this one? Is the ready mix aggregates going to be produced on site up there?
Yes, some of them will be.
The aggregate, the concrete, no, but all the other aggregates, filter gravels, not. The river aggregates are a precious resource on the site, so we've taken the lesser risk option to bring it from current certified aggregate plants.
So the filter material will come from around the dam site, if you like.
Thanks.
But there's a batching plant actually on site being set up.
Where did the well loan come from?
The well loan, it's from the Crown irrigation into SIL. So SIL has lent money to both Waimea irrigators and to TDC for the matter. All right, so no further questions?
If the cost blows out to 150 to 200 million, will you guys continue construction, or will there be more reassessment done?
Well, we haven't considered a case where it blows out to 150 million. I mean, it's
I heard most of these dams overrun and pretty double in what they anticipate was the first estimate is usually the case. And 50% overrun is pretty rare.
Yeah, it's not the research I've seen. To be honest with you. And like I said before, 78% of our costs are fixed. So I think the cost of overrunning is probably bigger with these guys than it is with us.
There was a robust ECI process, and that's why we've taken on the lump sum, and we're taking on a lot of risk to make sure this job comes in.
Okay, well, ladies and gentlemen, thank you very much for your time tonight. I hope tonight was informative and you've learned something about the dam. If there's interest, we will continue these sessions through the year, maybe once every 6 months to a year to keep you up to date. In the meantime, if you're interested, I'd encourage you to look at our website, to look at our Facebook site, and we'll keep posting photos. And once again, I thank you for your time. Thank you.